So in the previous video, we learned about that classification of instructions in 8085 based on the size as like 1 byte instruction, 2 byte instruction, 3 byte instruction, and then we had seen based on the operation it is classified into 5 groups. Those are called as data transfer or data copying instruction. After then second one is arithmetic instructions, third one is logical instructions, fourth one is branching or looping instruction, and fifth one is machine control instructions. So before going into the detail of these instructions based on their operation, we will see that the instruction format in 8085. So the very first field of this instruction set is here as a label. So this label is basically used whenever we are writing a program in the loop, as like by using that jump or call or some other kind of instructions where that looping is required, then we need to use the label there. As a label we can take it here as a loop 1, or we can take it here as a loop 2, or something else like as per the requirement or as per your desiredness. We can give the label name here in the different names. After then the second field is called as a opcode. So opcode means, for example, let's say we are writing the instruction as a move c comma b. So here this move is called here basically the opcode here. The reason behind that, if we are writing here as a move c comma a, so the similarity between these two instruction is both is data copying instruction, but the dissimilarity is here the operand is c comma b. It means their source register is b and their destination register is c. In this case their source register is a and their destination register is c. So both will come under the data copying instruction, but both will be treated as a different instruction here under the opcode of move here. So we need to write here the first this part will be opcode. After this c comma b or c comma a will be treated here as a operand. So this field is called here as a operand field. After this, as like whatever I had explained, the classification of instruction based on their size as a 1 byte or 2 byte or 3 byte, we can easily find out what the technique I had given previously about those instructions. So we can easily find out their size in terms of byte. And after this we need to find out the machine cycle. So once we know the clarity of the operations of this instruction, we can easily find out their number of machine cycle. And after then, if we know about that this machine cycle, then we can easily find out their number of t state. For example, let's say this move c comma b. So by default for any instruction, the minimum number of machine cycle must be one machine cycle. So the minimum number of machine cycle for any instruction, it must be 1. And by default the very first operation of any instruction is called as opcode fetch operation. So here it's very simple that how to find out this machine cycle. Then by knowing about the operations of this instruction, we should know about their size first, and after then their operation. Based on these two parameters, we can easily find out the number of machine cycle. So as per the definition of the machine cycle what I had given, how many times this microprocessor is accessing the memory, either the memory or the input output port, the sum of those are called their number of machine cycle. And as per the table I provided earlier in the earlier videos, that for that particular machine cycle, that as per their operation how many t state is required, we can easily find out those and we can easily write down here. So for this instruction, let's say move c comma b. So their opcode is simply here move. Their operand is C comma B, or I can say that this is the destination register, this is the source register, and their size will be 1 byte always, and their machine cycle, how we can find out? So in this case, if source and destination both are the register, that is called processor register, then we can easily find out their machine cycle. So their machine cycle means from the memory, this for the execution of this instruction, let's say for this move C comma B, their address is 2000H, and at this location their opcode equivalent hex code is stored. So this processor will be accessing this one to this microprocessor. So it is accessing only one time as a opcode fetch operation, and it will execute this instruction inside the processor, because this B or C register here, C and A register, these all are available inside the processor itself. So to access these registers, processor is not going outside of this processor. So that is the reason it is treated here as a one machine cycle, and that machine cycle is referred here as a opcode fetch. This is performing here opcode fetch, and normally for opcode fetch operation it is required minimum T state is 4 T state. So most of the opcode fetch operations, for most of the instructions, it will take only 4 T state for their opcode fetch operation. Very few require 60 state, so that list I'll give it in the further videos, how to find out or how to say that it is required 60 state. But most of the instructions, it will take only 40 state for their opcode fetch operation. So like that we can fill these fields, and we have to see one by one about all those instructions group wise. First we'll discuss about that data transfer or data copying instruction, after then followed with this arithmetic instruction, then we'll go for the logical instructions, then we'll move for branching or looping instruction, and after then we'll move for machine control instructions. So if you'll see that total number of instructions in this 8085 is having 256, and for all those 256 instructions we should know about their opcode, operand, size, machine cycle, T state, but it is quite difficult to remember all those. So here we will learn this code wise, group wise, and we can minimize those. So that is very simple. After learning these instruction sets in all the group, you will be very comfortable to answer any kind of questions based on this instruction, as like what is the function of this instruction, then what is the size in terms of byte for that particular instruction, then how many machine cycle it is required, how many T state it is required to perform this execution of this instruction. So here no need to remember all these five datas for each instruction. Once you'll be familiar after completion of this course or these videos based on this instruction set, you'll be very comfortable to answer any kind of questions based on this. So I hope so you'll learn this in better way, and in the forthcoming video I'll explain bitwise about all those instructions, and that you can remember with some more practice in the beginning days. After then no need to do all those things, you can answer all those fields based on that instruction very efficiently. So we'll see that further that each instruction in the forthcoming videos.